Question 5. This is about a reflector that was left on the moon, and we've got to complete this diagram. Okay, now you can see the ray of light coming in here, alright, and we know that the law of reflection is that the angle of incidence is equal to the angle of reflection. Okay, now we have to measure the angle of incidence and the angle of reflection from the normal line. The normal is perpendicular to the surface, so that angle there is the angle of incidence, and hopefully you can see that that's going to be 45 degrees in this case. Now it's important that you complete this diagram with a ruler. Unfortunately, rulers don't seem to work very well on my tablet. Okay, so I'm going to do it freehand, but that line there that you've drawn, that should be drawn with a ruler. Okay, and going back to the law of reflection here, going back to the law of reflection here, okay, that the angle of reflection is going to be the same as the angle of incidence, which is 45 degrees. Okay, now that ray there has got something important missing from it, okay, and it needs to have an arrow on there to show the direction of the ray. Okay, now that we've done it over there, exactly the same process over here. Draw the normal in. There's the angle of incidence, 45 degrees. That's the angle of reflection, and 45 degrees again. Make sure your ray's got an arrow on it. If you've done it properly, then this ray here and this ray down here should be exactly parallel to each other. Not very good drawing on my part. Okay, just a reminder that you want to be completing this diagram with a pencil and a ruler, okay, for best practice. Right, 5 part B. This is a calculation question, so we're going to get the first mark for working out the formula. Now this is giving us a velocity, okay, so what I'm doing here is I'm just writing down what the question tells me in terms of symbols. Okay, then the next step is to write down what the question asks me. Okay, so it's asking me to work this out, to calculate this value, and it's in kilometers, so it's asking me to calculate distance. Right, now if you think back all the way to topic 1, the formula that we need that connects these three things is V equals D over T. So I've got 1 mark for the formula. Now I've got to do the substitution. Just put the numbers in, and then to find the answer I'm going to do 300,000 multiplied by 2.6. Do it on a calculator and you get 780,000 kilometers. Look back at the question. Oh, that's a lot more than that. So where have I gone wrong? Well, the time is to go to the moon and back. So what I've done, I've worked out the distance to the moon and back. So to find the distance just from the Earth, I've got to take this and I've got to divide by 2. So there we go. To the moon and back is that far. Just to the moon is 390,000 kilometers, which is approximately equal to their answer, which was 400,000 kilometers. Okay, for the part C of this, it's a 3 mark question that's asking what can be deduced about the orbit of the moon from the information in the graph. Okay, and you can see that the time varies slightly. Okay, now you can see for a start off, okay, that it varies with a period of exactly 1 month. Okay, so it takes 1 month for it to go. Oh no, actually, I'll go back. It varies approximately the cycle of about 1 calendar month, and of course the lunar month is slightly shorter than that. The lunar month is about 28 days. okay, but they don't need that much detail. But if you spot, okay, that it takes about a month for the cycle to repeat itself, okay, then that'll get you a mark. The other thing is that if the time is increasing, let's go back to our equation up here, okay, if the time is getting larger, the speed of light can't change. So if this is getting larger, then that must be because the moon's getting further away. To get the third mark, it would be nice to use the data off the graph, use some of the numerical data off the graph. So you can see here that this is the maximum time that it takes, and this is the minimum time that it takes. So you could read that data off the graph to get the third mark in this question. And then of course when we've got that data, what is it, 2.447, okay, when we've got that data, if we wanted to, we could calculate the difference in the size of the orbit, so how much the orbit of the moon varies by. Okay, so you can use exactly the same method that you used in the previous part of the question to work out those distances, and the maximum distance is given there, and so is the minimum distance. So like many of the questions where there's multiple marking points, there's not just 3 ways that you could possibly get the marks here. There's about 6 different ways, but I've shown you the ones that I think are the best. Final question. As well as noticing this monthly pattern, okay, what they found is that every year, very slightly, the average time increases. So again, let's go back to that equation, velocity equals distance over time. Okay, this can't change, that's a constant. So if this number here is getting bigger, if this number is increasing, the only way that that can happen is for this number here to get bigger as well. So the logical conclusion to that is that if the moon is getting slightly further away from the Earth each year.